Hi, everybody. I'm David Speyrer, and this is Brian Jacobson, both programmers at Valve, and we both worked on Half-Life 2 and participated in the design of Half-Life 2. And today we just want to give you an overview of our design and production process on Half-Life 2 and try to distill some of the more useful lessons and processes that we learned over the course of that project. Now, as you might know, at Valve, everybody on the team collaborates on the design. We don't have the role of a lead designer, or we don't have any pure designers at our company. So programmers, level designers, animators, and writers, and so forth all work together to produce the design for the game. And the goal of that design is fun, of course, which is the kind of thing that's easier said than done, as you guys all know. Fun is really obvious in hindsight. People know it when they see it. But they might not know how to specify it in advance. And it's a problem with a lot of different solutions. Lots of different game designs are all fun. And different people have different ideas of what fun is. So it's also extremely subjective. And at the surface, it seems like game design really defies direct analysis. There's no sort of analytical way that you can take to come up with a game design. But we took an approach on Half-Life 2 that led us to believe that these kinds of fuzzy problems and other fuzzy problems that face games businesses, like community building and marketing, for example, can be solved through basically an engineering R&D approach. So what does an engineering approach look like? Well, you start off by defining your goals, things you want to achieve, and whatever constraints you might be working in, things like technologies or other constraints that your product has. Then you come up with an idea of how to achieve those goals. Perform an experiment to test the idea, and you want your experiment to be as unbiased as possible. And then based on the outcome of the experiment, if the experiment was unbiased, you can evaluate the quality of your idea. You can also then, periodically you want to make sure that your goals are actually the right goals for your product. Because sometimes you achieve your goals and they weren't quite as rosy as you originally thought, and you need to rethink your overall goals. Then you can repeat this whole process, generating new ideas and going through the whole thing again. And so it's an iterative process to getting where you want to be. Now, to apply this kind of a process, you have to go into it with a few key ingredients. You have to have the right attitude. You have to be ready to be wrong. If you knew what the right answer was from the outset, you wouldn't need to apply this kind of an iterative process. And so it kind of stands to reason that a lot of your ideas are going to fail in your experiments. And you have to be ready for that. It's also really important that your goals are stated in a way that's unambiguous and measurable. Because if your goals can't be verified, then that kind of torpedoes this approach. It's also important that everybody on your team agrees on the goals and that they're well communicated to your team. For example, if half your team is going after the hardcore market and half your team is going after the mass market, then your team's going to have trouble agreeing on things like whether your game is too easy or too hard. It's also really important that your tests be devised to be as unbiased as possible. It's really easy to create a test that, it's really easy to unintentionally influence the outcome of a test. Like drug companies use double-blind testing when they're evaluating new drugs, in which the patient and the doctor both don't know whether they're getting placebo or the real drug. And this is because really subtle things like body language and tone of voice on the part of the doctor were found to influence the results of the tests. So starting out, setting goals for your project, you can do a few things to set good goals for your project. And at Valve, we talk about something that we call product focus. And what this really means is caring more about the quality of the product from the consumer's point of view than caring about your individual contribution to the product. It's about sort of filtering all of your goals through the lens of the customer. Most of us got into the games industry because we like playing games ourselves. And it's really tempting to want to make the games that exactly we want to play. But, we want to be in this business long term, so we want to keep making money to keep making games. So it's really important that your customer experience be good and, your games be commercially viable. And we think that the single variable that we control most as game creators, game developers, is product quality. And this is the thing that correlates most highly with customer experience and increased sales. So to apply, engineering to game design, your goal is a fun game, obviously. And your game designs are your ideas, or your game mechanics are your ideas. And the experiments that you run to test your ideas are your play tests. Use that to generate new ideas and repeat the process. Now, when we say playtest in this talk, we're not talking about QA, which is really more about finding bugs at the end of your project. And we're not talking about balancing, which is about making sure, for example, all your weapons work well together, and no one weapon is obviously superior to all your other weapons, that sort of thing. And we're not talking about focus testing, which is more of a marketing, finding your target demographic type of exercise. We're really talking about, is the player having fun when they're playing your game? So when you're running your playtest, you're trying to figure out, first and foremost, are your players having the experience that you designed? And that's sort of a mechanical test. And secondarily, is that a desirable experience? And the things that you observe in your playtests directly drive your daily production decisions. For example, your game code. At Valve, this is where most of our game core mechanics are implemented. And we're looking to see if those are working properly and if they're creating a fun experience for the player. Effects art is often designed to communicate some key information to players, like where a creature's attack is going to strike or something like that. And we want to see if that's communicating the appropriate information to players. Your environmental art is often designed to lead the player's eye to the right thing. Like in Ravenholm in Half-Life 2, we had a door that we didn't want the player to see until they had solved a puzzle first. And so we carefully designed our environmental art to make people tend to miss the door the first time through the space, and they always had to double back after solving a puzzle and find the door. Your sound design is it's trying to convey a mood or communicate key information to the player, and so you're evaluating that to see if that's doing its job. And then training. Are your players acquiring the skills that you're trying to teach them? And are they able to use those skills later in the game to solve problems? Pacing is all about varying, the degree of action and puzzles or downtime and storytelling. We found that if we put players through too much combat nonstop, that they just got numb to it. And we started calling it combat fatigue. And we knew that if players were getting just kind of bored by relentless action, that it was time to give them a puzzle or some storytelling or downtime to kind of bring their excitation levels down and get them ready for more action. And then, of course, you're trying to see if your game is too easy or too hard. So this is what a playtest at Valve looks like. We go down to some place like Electronics Boutique, and we ask people there if anybody wants to play Half-Life 2 or whatever game we're working on. And usually we get, a couple of people. So we hustle them into a van and take their money. It's great. We bring them to Valve, and we bring them into a room that looks basically like, a room in their house. It's got a couch. It's got a computer set up. It's got an extra monitor for the team to look at, to watch from afar. And we bring everybody who's responsible for design and production into the room of the section being tested. And that's usually a pretty small subset of the whole team. On Half-Life 2, it was like 6 people out of a team of 40 or 50, depending upon when you're talking about during the project. And during the playtest, no one's allowed to talk to the player until the end when we ask them questions. So why do we do these things? Why do we make sure that everybody's there in the room? Well, first of all, there's nobody better qualified than the production team to evaluate the results of the playtest. I mean, they know what they're trying to build. They know what they want to happen. And so if it's not working or not happening, they're the ones who are going to really see that most quickly. It also really helps prioritization. When they see the playtest firsthand, they know exactly what the worst problems are, and they want to go off and fix those problems. And they're really motivated to fix those problems, too. I mean, there's nothing more painful than sitting through a playtest, watching it just completely tank. We had a playtest very recently where a player, we'll call him Gary McTaggart, was lost in this kind of mazy section of the map, and he kept hitting this T intersection. And every time he hit this T intersection, he turned right, which sent him back into the part of the map that he'd already been in. We watched him do this for an hour, over and over again. And we left that playtest going, okay, the next player is going to turn left, and we're going to make sure that happens. So we relit the map and added some landmarks and things like that. And it fixed the problem. But it's just incredibly painful to watch somebody fail miserably in a playtest. So why do we set it up like a living room, and why can't we talk? Well, this is really to create a really unbiased test. We want the player to feel like they just bought the game and they took it home to play it. We're trying to simulate a real customer experience with our game. And, giving hints would just completely invalidate the test. You can't answer any questions that they ask during the playtest. We always just say, hey, sorry, pretend we're not here. And you also can't reward the player, personally reward the player while they're playing. You can't cheer when they finally succeed at something. And you can't hoot when something really cool happens as much as you want to, because it's fun watching the playtests when they're going well. But, that artificially makes the game more rewarding than it really is. And, when people buy your game, it has to stand on its own feet. So we try to stay completely quiet during the playtest. And we bring people from places like Electronics Boutique or wherever because we feel like people from our own company and people from other games companies are just too steeped in the language of games to really create an unbiased playtest. There are so many subtle clues and training that they just pick up automatically because they're familiar with game design as professionals. So it's really important that we get people who are most like our actual customers. So at the end of the playtest, we question the playtesters. But you can only rely so much on questioning because, for one thing, your playtesters, they might be fans. They're probably fans of your game, and so they might feel like they have to praise the game to please you. Even if they didn't have fun at all, they might feel like they have to say something good, and or they might feel like to be a good playtester, they have to find something to criticize, even if they didn't have anything really bad happen to them in the playtest. How did I go back? There we go. The other problem with questioning after playtests is you might plan to question playtesters about something, and then during the playtest, they completely miss that thing. And so you can't question them about it at all. We had this problem in Train Station, the early part of Half-Life 2, when the player sees their first Strider walk by. And most players in early playtests just never saw the Strider at all. And so we couldn't ask them about what they thought of it or how it made them feel or anything like that. But it did tell us that we needed to make sure they saw the Strider. And so we did some level work to ensure that, basically sort of leading their eye that way in advance. And questioning, if you ask the right questions, they need to be kind of non-leading questions, can really be good for measuring things like storytelling and perception. Like, if we want to see how effective our storytelling is, then after the playtest we say, tell me the story of what happened during your playtest. And if they tell a pretty accurate story, or, the story that basically we wanted them to get, then our storytelling worked. It also measures, you can find out through questioning what players perceived and what they didn't perceive. Like in the Citadel in Half-Life 2, we had created this disintegration effect that happens when you throw the Combine energy balls at the soldiers. And at the time, it was the first place in the game where we introduced that effect. And so it was really important to us that people see it. And we would see playtests where players were throwing the Combine balls all over the place, disintegrating soldiers willy-nilly. And we thought, great, this is working really well. And then after the playtest, we asked the probably somewhat leading question, but we thought it was a given that they got it, of, so at what point did you realize that the Combine energy balls dissolved the soldiers? And we had lots of playtesters say, huh? They did? I didn't know that. And it was just all luck. They were just blundering into it. And so we realized, okay, we need to set up a really staged training event where there's nothing going on and you get to disintegrate a Combine soldier. So we hire people from all over the industry, and one thing that new hires consistently seem to comment on is that our playtesting practices are different from the companies that they came from. Often they say that at their companies, the playtesting happens pretty late in the process, and it's usually about fixing the worst of the design problems and, basically doing QA, fixing bugs to get ready for shipping. And we feel that this is really a shame because playtesting is where we make the vast majority of our most important changes to our game. So we try to do it as early as possible on the project to get the most value out of it. So when we're building a new section of the game, we'll create as little as possible to test some of our fundamental mechanics, as little as 15 minutes of gameplay. And then we start playtesting that right away. It doesn't matter how rough it is. It's just we want to test as little as possible to validate our mechanics. And then that generates a list of work, and we prioritize that work for the next week, and that's when our next playtest happens. And we would do that, we did Half-Life 2 basically in sections, playtesting a section at a time, until it was no longer excruciatingly painful to watch the playtests. And then we felt like we were pretty much done with that section. For example, this is a map from Half-Life 2 as it looked when we first started playtesting it. And it's not even pretending to be final art. The walls are orange and the floor is gray, and the rails there are they're just what was necessary to keep players from falling off the catwalks. And this is all about, for us, reducing iteration cost in the early phases of construction when we don't know if the mechanics are even going to work out. So, we don't want to overinvest in art before the mechanics have actually succeeded. This is that map as it looked when we shipped, with all of its final art in place. So next, before I hand it over to Brian, we're going to watch a movie of the playtesting and iterative development process in action on Episode 1. And you're going to notice a few things. You'll notice that we didn't build in orange on Episode 1. And this is really because we had a bunch of art assets in the bank for City 17 and its environments. And the level designers just felt like it was faster for them to use existing themes to build the gameplay prototypes. And you'll see things like cover points move as a result of playtests. And you'll see the art team do experiments with lighting and skyboxes. And this period spans about 6 months of development, I believe. And we were doing 1 to 2 playtests a week.
All right. So I'm going to talk in a bit more detail about using playtesting as the fundamental backbone of your production process. So as David was mentioning earlier, one thing that we felt was really important was to have continual playtesting to help us prioritize what to do next. The basic concept being that we wanted to do the smallest amount possible that helped us learn anything at all about the player experience. Usually our iteration time was about 1 to 2 week increments. We found that shorter time than that between our increments meant that we didn't really have enough time to make substantive change, or enough substantive change to measure something new in the new playtest. And if we took longer than that time, we felt that it resulted in some churn and flail largely because the longer it took for us to play test, the less certain that what we were doing was actually helping the customer experience or was the most important problem for us to solve at the time. So in order to maintain a consistent playtesting schedule, we had to make sure that we eliminated all obstacles to that playtesting, which meant that we tried to not allow theoretical problems to avoid playtesting or to prevent us from playtesting. The things we were worried about, like missing training or whatever, might not actually be problems, and a playtest would show us whether they really were or not. And if it turned out that they were actually problems, the playtest would give us additional information, namely, which problems are the most important problems, and therefore which ones we should solve first. In addition, the playtest could generate for us ideas about how to solve our problems better. For example, let's say that we were missing training on a particular gameplay element, and when I talk about gameplay elements, I mean mechanics, NPCs, weapons, vehicles, that type of thing. So if we were missing training for one of these elements, the player was going to have to figure it out himself somehow. And often, or sometimes anyways, we would find that the playtester would teach himself how to use an element in a more fun way than we were initially planning. And we incorporated that into the design. Finally, as Dave mentioned earlier, again, we tried not to worry too much about how it looks. We feel fundamentally that art production is just less risky than gameplay production. It's much, much easier to make a fun map look good than a good-looking map be fun. And again, overinvestment in art too early cost us more in terms of iteration time and reduced the amount of playtests we could do. Now, there are a number of benefits you get if you use playtesting as the backbone for your production process. The first thing is it's really useful for learning. As Dave mentioned in an earlier example, we were really surprised to discover that people couldn't perceive the fact that the Combine soldiers were dissolving when they were hit with the Combine balls. And through that playtest and a couple of other playtests, we basically came to realize there's just this fundamental aspect of human psychology, which is they can't perceive anything at all, really, when they feel like they're under threat. They're completely 100% focused on dealing with whatever threat that's after them. And so as a result, we learned this new sort of design tool that we added to our toolkit, which was never introduce anything while the player's under threat. So we never do story during threat. We never do puzzles when the player's under threat. And no new mechanics or elements. That's just something we apply to all of our future design as a result of stuff we learned through playtests. It also is really easy, if you use continual playtesting, to measure each element's incremental value or damage that it does to your game design. One example of an element in Half-Life 2 that damaged our game was in Ravenholm. We added the behavior where the fizz cannon could punt zombies, which would cause them to flinch and do a little bit of damage, on the theory that more interaction is better. What ended up happening was a bunch of our early playtesters, including Gabe, when he played this, just ran around nonstop punting the zombies and completely missing the fact that they could pick up saw blades or propane canisters and use those, which were much more fun ways of killing zombies, as we knew at the time, since we had already done those elements. So as a result, we decided that element was actually hurting our game, and we removed it. Using continual playtesting is also a great way to help you avoid design argument. At Valve, prior to sort of our adoption of this process, and in my experience at other game companies prior to Valve, oftentimes the sort of character of design conversations was structured around ideas and coolness. Like someone would say, hey, I've got this idea, and isn't it cool? And someone else would say, my idea is cooler. We should do that instead. And it wasn't really a particularly productive way of framing a design discussion. But when we moved to this kind of a process, the discussion changed in character more to a conversation about problems that we actually watched and potential ideas for solutions for those problems, which was a much more productive way of framing the conversation and was always focused on like the actual problems that we saw our customers experience. Finally, you can use your playtest results to drive other aspects of production. For example, if you do your gameplay iteration before heavily investing in art, you can use what you learn to tell the artists about various constraints they should apply before really investing in their art. Like if players are getting lost in a particular part of the map, you can say, hey, make sure when you do the art for this area, we want you to focus attention here. And it helps them avoid throwing away work that they've done, which is something that artists, of course, hate. Now, a couple of rules that we tried to apply to this process to help it be as effective as possible for us. Firstly, we tried to realize that solutions to our playtest problems could themselves be iterative. If we, let's say we saw a playtest problem and we had two potential ways to solve it. One way which is going to take about 2 months, but we were pretty sure it was going to fix it. And another way which is going to take a week, and it might fix it, but we weren't really 100% sure. We would usually do the 1-week solution first and then immediately playtest it. If it turned out to fix the problem and no playtesters ever had it again, we were done. And the nice thing about that was it helped us avoid overinvestment in solutions to problems. And we just did the amount of work necessary to actually fix what was our issues. Another thing we tried to do was solve the problems that we ran into in the right order. For example, if we were lacking training, we usually wouldn't try to solve the training problem in the game until the element we were trying to train was made to be fun. If we didn't succeed at that and we ended up cutting it, then all the work we invested in training would have been a waste of time. Usually for new elements, we would make a little tiny test prototype map that playtesters would go through to sort of just teach them the elements before actually playtesting. That was kind of the way we usually solved that. Another thing that we tried to do is to not overcorrect. This took us a little time to learn. When you go into a playtest and you watch it fail completely miserably, you just want to kill yourself and not ever have that thing happen again. And so your initial instincts can oftentimes be to just want to remove the element completely so you don't ever have to look at it again. But you have to remember that the sample size that you're dealing with is usually quite small. And as a result, we would tend to look for trends instead and not get super happy or super unhappy with an element until we've seen it playtest the same way a couple times in a row. Another thing that it took us a little while to learn was to not oscillate. Sometimes there are just problems for which there's no correct or best answer. The airboat in Half-Life 2 is an example of this. Some of the playtesters, half the playtesters like the steering this one way, half the playtesters like the steering another way. We had endless debates about which way we should do it. We switched back and forth and back and forth. And in the end, we just needed to realize a lot earlier that it was just not going to matter and we should have just cut off debate and stopped wasting time. Finally, we tried to finish our successful elements to a nearly shipping level of quality before moving on to the next element. This really helped us with the evaluation of the incremental benefit and damage new elements had in our game. There was a point in our process where we had a whole bunch of sort of half-finished elements, and when a playtest went bad, it was sometimes not really obvious what the culprit was. We couldn't really point to any of these half-finished elements and say, well, that one was obviously the one. But when we switched to this kind of approach, it became really obvious what our real problems were and what we should be focusing our attention on. Now, there are a number of other product-level benefits that you get if you adopt the approach of finishing your gameplay elements to a nearly shipping level of quality before moving on to the next one. Firstly, and in my opinion, most interestingly, it helps you schedule your project to a particular quality metric. Now, what I mean by that is that if you think about the typical trade-off of scope, time, and quality, many game companies typically are fairly locked in terms of time, either because of financial reasons or publisher demands. And they oftentimes lock scope fairly early on in the project. And if something's going to slip, it oftentimes is quality. But if you develop your game iteratively and finish each one of your elements to a nearly shipping level of quality before moving on, at any point in time, you've got a game which you can probably ship, even if it's a little bit too short. Which means that you can lock on quality and time and slip on scope if you want in exchange, if you don't make your original goals. The high-level way of thinking about this trade-off is, would you rather make 20 hours of an okay game or 10 hours of a good game? Another thing that this approach lets you do is helps you scope game design risk for key features of your game. If you think about pretty much every single new game design element that you add to your game represents schedule risk. You don't know exactly how long it's going to take to make that element be fun, or the amount of time it's going to take to make the tools or the technology to make that element shippable. So by doing your elements one at a time in a row, starting with the ones you think are going to have the most promise, then at the point at which you run out of time, say maybe you hit alpha or you're nearing alpha, you just decide, okay, well, I'm going to stop, and there's no more elements I'm going to add to my game. And you just ship with that. And the elements you have are good. Finally, not finally yet, another thing that this lets you do is it helps you optimize your game towards the most successful elements in your game. If you know pretty early on in your process that you've got a couple successful elements, say you've got elements A and B, then you can make some decisions about how to steer your game. If element A is more fun than element B, and you know this early enough, you can make more of your game be about element A, thereby increasing the overall quality of your game. And if you also know, let's say A and B are equally fun, but let's say B is more expensive to make, then you can still make more of your game be about A, and you have an equal quality game, but you got more of it. In Half-Life 2, the Super Fizz Cannon at the end of the game, Super Gravity Gun, sorry, at the end of the game was an example of this. We didn't initially plan to make the Super Gravity Gun, but the Citadel levels were amongst the last ones made. And at that point, we knew that the Gravity Gun was a really successful element of our game, so we decided to make more game about that. Finally, this process of getting your elements to a nearly shipping level of quality before moving on helps you measure risk, speed, and cost. The high concept here is if you have made 1 hour of game to a nearly shipping level of quality, you can use that to extrapolate out to how long it might take you to make 5 hours of game. Of course, you might want to take this with a grain of salt since we're not historically known for our good predictions. So, how do you apply this process to a larger scale project, like 50, 60 people? Now, as Dave mentioned earlier, typically these the production teams that are watching playtests and making production decisions were fairly small, about 5 or 6 people. And the reason for this was because we felt that was a pretty good size in terms of meeting size, and decision-making could be pretty agile. And so we decided that it would be a bad idea on a big project to make that production team be, say, 20 people large. It would just bloat the process and slow everything down too much. So instead, what we decided to do was to make 3 nearly independent design teams, each about 5 or 6 people large. And we split the game up into chapters which were split amongst the various design teams to create. So how did we do this in such a way that we didn't end up with a game that felt like 3 completely different games stitched together? Well, what we did is we tried to constrain the types of decisions that these design teams made, thereby creating sandboxes for them to work in that would allow them to work and not disrupt the work of the other design teams. The type of problems that they were trying to solve were really the level design and minute-to-minute gameplay types of decisions. In order to make this work, we basically had to establish a number of processes to help us with our global decision-making process, because the design teams weren't really working in that space. And so the next thing I'm going to do is talk a little bit about the various processes we used to help us make global decisions that the design teams then worked within. The first thing that we did was to try to establish initial constraints, which we did during a pre-production phase, where we defined a bunch of our initial product level decisions, including story elements and settings, art concepts and style guides, the major design principles of our game, like all training should occur within the context of the game. We created prototype maps during this phase for NPCs, mechanics, weapons, and vehicles, whose goal was to basically illustrate as many ways possible that we could use these elements in our game. By the time we were done with our pre-production phase, we basically had a pretty clear sense of our chapter progression, the major gameplay themes we would be attaching to each one of those chapters, weapons and NPCs that we were pretty sure we were going to introduce in those maps. And again, then we handed those maps off to the various design teams, the various chapters. Some of the decisions that were created during the pre-production phase were treated as constraints by the design teams. For example, story settings and design principles. The root canal team, for example, were given the story constraint that at the beginning of their levels, Gordon would start out on the run from the City 17 forces, and as a result of a failed teleporter experiment, which alerted him to the presence of his presence to the forces. and ended when Gordon had escaped the city forces in the safety of Eli's lab. Other decisions that were made during this phase were treated more as suggestions by the design teams, and this included mechanics, weapons, enemy NPCs. And basically, in order for a design team to decide to use one of these elements, they basically had to make the commitment to take that prototype version of the NPC and bring it up to a shipping level of quality so that they could ship it in their levels. Some of the elements that were prototyped were just never adopted by design teams, either because it was deemed too expensive or because they tried to do it and it just failed in playtesting. Some examples of this were the stalkers that you see at the very end of the game in the Citadel and the Tentacle, which is in the E3 2003 demo. There were other major elements, though, that we did ship that didn't even exist during this prototyping phase. And usually this happened when a design team sort of went off on its own and did a little mini pre-production phase on its own as a result of what they learned in playtesting. The Super Fizz Cannon gravity gun, I keep calling it Fizz Cannon. Super Gravity Gun at the end of the game was an example of that. A second global process that we tried to use to help us with our global decisions was to promote design economy, which is really the reuse of existing game elements in as many new ways as possible in our game. It's really useful for helping with global consistency because it makes more of your game be about the same elements. And it helps with global quality because it means more of the design teams are adding polish, new behaviors, new interactions of the existing game elements that are there, thereby making more of your game be about high-quality elements. Now, some of these gameplay elements were designed in isolation by the design teams. So in order to expose other design teams to that work, we ran periodic team-wide playtests. And just naturally, the successful and fun elements were picked up by the other design teams and used in their levels. A third process we put into place was to establish strike teams, which were formed to address cross-team issues. Some strike teams existed for the entire length of the project. One example of this was called the Weapons Cabal, which consisted of members of each of the design teams, as well as some other members. We made sure that all the design teams had a presence on this cabal so that they could all apply the various constraints they wanted to the weapons design to make their levels work. Most strike teams, though, were more transient and usually occurred when a design team was trying to use another design team's gameplay elements. And really, like, the thing that we tried to do here is to make sure that we didn't introduce schedule risk when another team was using when two teams were trying to use the same element. And the way that we did that was to apply the constraint that decisions made in gameplay elements in well-tested maps couldn't be changed. Namely, a design team couldn't by changing an NPC's behavior, cause another design team to go back and retest their levels. That was deemed too expensive. Now, most of the time, that constraint was pretty easy to use. Because most of the times, a design team was just adding a new behavior or a little bit of polish or whatever, a new interaction to these elements. There was a couple occasions where we ran into problems with this, where there really wasn't a great solution. The Metro Cops was an example of this in Half-Life 2. They were originally developed for the end of the game, and when they were brought back to the beginning of the game, they were just too hard. And so we didn't have a good solution. We couldn't make them easier because it would cause a retest of the end of the game. So instead, we just made an easy mode for them, where they did less damage and they took less damage to kill, and it just worked because there was a big section of the game where you don't see Metro Cops, so you don't perceive the fact that they're actually more difficult at the end of the game. Now, a final process we put into place to help us with our global decisions is something that we called the Overwatch Cabal, whose job it was to evaluate global product-level quality at alpha, which was the first time such an evaluation could be made, because it was the first time our game was playable from beginning to end. The job of this cabal was to communicate the highs and lows, the highs to keep or amplify, the lows to cut or fix, to all the design teams. This list of highs and lows was constructed from company-wide feedback that was generated during a company-wide playtest of the game that we ran when we hit alpha. Now, this Overwatch Cabal consisted of members from each of the design teams to let them all have a voice in the evaluation of their work. as well as members of the art, sound, and animation teams, and the writer was on it too. So we had every aspect of production and every aspect of the customer experience evaluated. Now, one thing that the Overwatch Cabal did not do was to give any specific feedback about how to solve these problems to the design teams. The design teams were 100% responsible for fixing their problems. The reason why we chose this is because we felt that the production teams, the design teams, were going to be able to make way better decisions about how to solve their problems because they were way closer to the implementation that they had in the first place. I mean, they watched all the play tests, and they know what players responded to well. They know how expensive it was to make all the things in their levels. So they were the ones who were really going to be able to make the best decisions about how to solve things. All the changes that were made by the design teams to fix these high and low problems were done during an alpha period, which lasted about 4 months long. So one thing that was really important for us, again, was to not incur schedule risk during alpha. And to do that, we applied a number of constraints to the ways in which design teams could solve the problems identified in the high-low list. One really important thing is that we made sure that we applied the constraint that they could not introduce new gameplay elements. It was just deemed too risky. We also strongly encouraged the design teams to be ruthless and cut their worst problems because it meant that they would have more time to invest in improving the stuff that remained. One thing that we did encourage them to do, though, was to add as much density as possible using existing gameplay elements. Because the point at which we hit alpha, we were experts in making that game. I mean, we knew all the little quirks and tweaks and performance implications of all the various parts of our design. And I can't emphasize how much stuff was added to Half-Life 2 during just this 4-month period using that approach. The number of examples of things we added to our game is really too numerous to mention, but to give you a sense of some of the magnitude of some of the changes, the sequence at the very beginning of the game where the player is chased through the tenements along with the citizens by the Metro Police didn't exist at all at Alpha, and it was added during this 4-month period. Now, there were certain types of decisions that we also tried to postpone even thinking about until we hit Alpha, because we didn't think that they could be addressed until we really had a global sense of the game. Things like pacing, difficulty, and variety are really best evaluated once you have a global picture of what your game is. And things like chapter-to-chapter inconsistencies were addressed during Alpha. This was a natural consequence of our 3 design team structure. Just the handoff points where one design team work ended and another one's began just were typically nonsensical at the beginning of Alpha. Oh, and the last point I was going to make is just simply like, all the changes that we did here hugely improved the quality of our game during just a very small period, 4 months. But at the end of that period, that was it. No more changes were made to our game, and we went into beta, which was a fairly short period, and shipped our game. So that's all we got for you. Some things to take away. First of all, game design is a process or is a problem that you can apply engineering principles to really help you understand that you're doing the right things and improving the customer experience. Make sure your production teams drive your design. They're the ones who are going to make the best decisions because they're closest to the inherent trade-offs of the implementations that they're going to do. If you expose your production teams, your design teams, directly to your customers through a continual playtesting process, you'll be guaranteed that they're solving actual customer problems and the most important customer problems. Large teams can use this technique of iterative playtesting if you have the appropriate processes in place to help with your global decision-making. And finally, make sure you, in your schedules, allow for a final iteration over your entire game once it's playable from beginning to end. We can't emphasize enough how important this was for Half-Life 2 and how much it improved the quality of our game. And we believe this is true basically because we fundamentally believe that every decision made later in the project is a better and more valuable decision because it's informed by all the experience that's happened up to that point. So that's pretty much it. If you're interested in seeing this process in greater detail up close, Valve's hiring. So talk to us. So I guess at this point, we'll open it up for questions. There's, I guess, a microphone over there if you guys want to use it. So.
Hey. Over the course of the game, how many teams did y'all have to create these little mini sections of the game as you went along? And how many teams did you have at the same time? And what was the good balance to keep it efficient and continually make
the question
content?
is, how many game teams did we have at the same time during
like
production?
the little sections of the game. Did the whole company work on it, or did you have 2 or 3 parts going at the same time? Or?
We had 3 parts going at the same time. So, for example, the prison, root canal, and the train station were all being developed at the same time by design teams that were each 5 or 6 people large. And then we had 3 other teams outside of that, an art team, a storytelling team, and a sound team that collaborated with the design teams to solve those problems in the levels.
Thanks.
How do you guys handle like positioning of team members? You talk about the different cabals and the design teams you had. Do you guys sit people next to each other? Do you find that works better? Or
Yes.
So the question is, how do we handle the location of our people? Yeah, we tried to co-locate our team members as much as possible. So we basically formed these cabal rooms. We called our design and production teams cabals. We would form cabal rooms that would have as many of the cabal members as we could fit in the same room. And that was usually like a couple programmers and a couple of level designers and maybe an animator.
Howdy, I have 2 questions. The first one is, how much time elapsed between your first playtest and your shipping of the title?
You mean for a given...
Well,
for Half-Life 2.
That's kind of a hard thing to describe. Let me describe the kind of process by which we did it. Usually, a chapter was allocated a particular amount of time, which was 3 months? 2 months? Something like that. On the order of 3 months, say, for a chapter. And so the chapter would start playtesting usually within about 2 weeks or 3 weeks or so of the initial work on that chapter. And it would last for however much time we allocated. Again, I'm forgetting if it was 3 months or something. Something on the order of 3 months. And then we also then did more work on those things kind of after alpha. Like we did a whole other pass over all of our stuff at alpha. So more work went into it during that 4-month period. And in the case of RMAP, for example, there was a major milestone at alpha when we had everything playable, and kind of in the 2 months prior to hitting alpha, we were looking at globally all the chapters that we were responsible for and trying to figure out amongst our chapters what were our low points that we needed to fix before we hit alpha. And so we kind of were shifting our work a little bit between the chapters at that point as well.
I guess the question I'm asking is, what state was the game in where you were able to play test it? Like, how much...
technology?
Yeah, the time between when you shipped to when you were actually able to play test.
Years. It was years before we shipped that we were actually playtesting.
And I guess I was wondering, do you have any recommendations for teams who, if they're starting a whole new project of, where the technology may not all be in place, of how they could apply playtesting when they don't have an underlying tech, or if there's a good foundation?
That's definitely an issue that we're kind of experimenting with. Right now at Valve, we're trying to do basically iterative technology development, where we're trying to solve 1 or 2 major technologies at a time and not try to do them all at a time, because that was one of our fundamental lessons from Half-Life 2. It took us a long, long time to get the engine up and running when we tried to address multiple technologies at once. So I would suggest that there's actually 3 ways that you could approach the problem. The first way is try to do something iteratively, where you take your previous game's engine, add a couple features that you want to use to drive your new game design first, and then just, incrementally create more new designs as you add more technology to your existing engine. You can also do that with a licensed engine as well. And then the other one that I've never tried to do before, but I'm interested in trying to see would it be possible if you're starting completely from scratch? Like, what's the point, and in what order can you order your technology development so that you can play test as early as possible. Like, it seems like you could optimize your technology development around that axis. So let's say that you decide you're going to heavily invest in AI or something like that, and you're going to not hugely heavily invest in, say, rendering. You just have boxes or something like that. Just something really simple and not particularly optimized and not solving the problems of scalability, things like that. You know, I'm not 100% sure this is possible or what the costs would be involved in this because I haven't done it myself. But it seems like you could theoretically structure your development like that, trying to heavily invest in those technologies that are going to be core to your gameplay and minimally investing in those technologies that are not, so that you can get to at least something rough as quickly as possible.
Okay. Thank you.
How long were you in your pre-production phase, and how did your team's dynamic shift, maybe in size or even in organization? Was it drastic? You know?
Our pre-production phase was really kind of extended by the fact that we were building major technology systems at the same time. So it lasted pretty much the first half of the project that we were basically never getting anything better than a prototype of some piece of gameplay. And it was really in the last couple of years of the project where we were in what I would call true production, where we were building things that were actually going to ship. But because our engine platform was changing so much, and we had, you know, giant features like physics, you know, that were in the works, it made it really tricky for our level designers to create things that they knew were gonna work.
Half-Life 1. Half-Life 1 to Half-Life 2, the difference in the design processes. Was there any way, I mean, Half-Life 1, part of what made it special to, I guess, a lot of reviewers, at least, and me, was the atmosphere. And then, I guess, maintaining that in Half-Life 2, and then the way you said you split it up into chapters, how do you maintain that across the board? And did the design process really differ drastically from Half-Life 1 to Half-Life 2? And was there a lot of reconciliation going on?
So the question is, how did we maintain atmosphere with multiple design teams working on different parts of the game?
Yeah, and I guess how much did the design process itself evolve from Half-Life 1 to Half-Life 2?
Okay, so...
Was it entirely different?
So how did the design process evolve from Half-Life 1 to Half-Life 2? Well, it was mainly a difference of scale. In Half-Life 2, we had to have parallel design and production teams working at the same time because we had too much game to produce in the time that we had, so we had to do it in parallel. Whereas Half-Life 1 was more of a serial process. And the way that we made our art and environment and mood consistent across the entire game was partially by centralizing our art. So there were people on the art team that actually worked on most of the maps in the game to establish things like style, theme. Like City 17, we created what we call style guides, which are, here's a city block with a bunch of buildings and how the streets and curves look. And then those themes were replicated by the production teams. And the same for, the canals and the coast and the citadel. So mood, well, in terms of environmental themes, it was a somewhat centralized process.
All right, thank you.
Sure.
I have two sections of question, depending on the answer to the first section. The Overwatch cabal. How big was that? Because it sounded like there was so many people in it.
7? Probably about 10 people.
Oh,
10. Okay. So how did you maintain, so you don't argue and quabble and actually get somewhere? Too many cook problems, or did you experience that at all?
So the question is, did we experience too many cook problem with the Overwatch cabal?
Yeah, meetings with many people often tend to, just...
The goal of the Overwatch cabal wasn't to design, so that simplified things. It was really to act as educated critics, identifying the worst parts of a section of the game that really needed to be fixed before shipping, and identifying the best parts of a certain section of the game that should be amplified or replicated in other parts. that sort of thing. So it was pretty easy to build consensus within that group. I can't really say why it was, but
thank you.
Sure.
How did you guard against statistical anomalies in the playtesting? If a playtest subject was particularly incompetent, did you make a decision to change, or did you always test it on 3 people?
We typically looked for trends. We typically wouldn't get super happy or unhappy with an element until it playtested a number of weeks in a row the same way with a number of different playtesters. But you're right. You run if you jump too quickly in a direction as a result of a single playtest, you're running the risk of that for sure.
And in fact, that's kind of one of the fuzziest parts of this process is evaluating, the playtest itself. And the best advice I have for that is once you sit through enough playtests, you get an instinct for whether it's going well or poorly by watching the player and seeing how they seem to be reacting to things.
Okay. What was your organizational and management structure, both within a cabal and then as the cabal is related to the company as a whole?
Okay. We had, again, we have no dedicated managers at Valve. Most people are, spend most of their time doing some production work of some sort and then some management on the side, essentially. And so we had like a lead for our art team. We had a lead for our story team. We had basically a sound guy, so there wasn't really needed to be a lead there. We had a project lead, and then we had kind of leads for the 3 design teams. And so I would say like most of the kinds of decisions were made in a sort of collaborative way. Like the project lead, what he would do is once a week he would come over to the 3 design teams and basically like try to basically act as a critic for our decision making. Like have you taken this into account? Like what is your decision? What's your process behind your decision making for this? Basically testing if we thought about it, right? Not actually suggesting specific things to do. And with the art and sound and story teams, those tended to be more collaborations. Like they had specific goals in mind for telling story, and what they would do is they would periodically meet with the various design teams and say like, okay, let's talk about the various goals for story in this area. Like they would have goals from like the high level, like what is the story we want to tell. The design teams would often have goals from the, players are not getting confused about what they should be doing here. We need to come up with a story element to help justify that. Or we need to do some training here for an element. How do we hook that into the story somehow? So there was kind of like this back and forth collaboration on those 3 fronts, essentially, between the leads of pretty much the leads of the design teams and then the leads of the art teams.
Okay, so there was, a single lead within each cabal.
Yeah, but it's important to realize that the lead is more like you want to make sure the meetings are on track, that the meetings are accomplishing the goals that you're trying to accomplish. You want to watch schedule, that sort of thing. It's not the leads sort of ideas are not right. So they have to pass the cabal as a whole.
Yeah, like
just like any other idea.
So lead is more an organizational facilitator.
Yeah,
exactly.
Yeah.
He's like we kind of felt like it was a failure when the lead actually had to like make a call on something because people in the group couldn't agree on something as a result of say watching a play test, which usually tends to lead towards fairly rational and collective agreement on things.
Okay, thanks.
Sure.
I'm just curious about the number of playtesters you used, and in general areas. For example, I'm imagining that some levels perhaps required a lot more iteration because they generate all sorts of problems, and so maybe you went through many more playtesters for some. So I'm just imagining and sort of wondering what were common numbers of playtesters that you sent through a given level.
A chapter typically had about 100, on the order of 100 playtesters go through it. I would say.
Yeah.
And each chapter, I think, had roughly the same order of magnitude. There was no single chapter you could point to that was like, oh, these guys had to have 1,000 playtesters or 10 playtesters. It was pretty much consistent. We just had 1 or 2 playtesters in every week, and given that all the chapters took about the same amount of time to develop, it just worked out.
And I assume you had some administration person, assistant producer or something running around going from boutique to boutique searching for these people? Or
yeah, Eric Johnson had lists of people that wanted to play, and we just asked him for new names. Now we've put all that on a wiki page on our intranet, so that when we need a name, we just go there and get the next person from the list.
That's cool. One last question. I've lost it. Got it. Thank you.
Okay. If you remember, you can come back. Sure.
Okay. Does the engineering side of the business, in other words, the people doing the source engine, did they have a formal methodology they were following for getting their work done, like Unified Processor, Agile, or Scrum? You might not know about what they were up to, but is there that kind of formalism in place at Valve?
I would say we were informally an Agile development house. I don't think that we don't, for example, strictly adhere to the practices of extreme programming and doing all the pair programming and whatnot, but we do try to do lots of testing and that kind of thing. We try to continually implement the simplest possible thing, and have the shortest possible time between the implementation of our technologies and something that we can test and run and make sure it's working. So in that sense, we're agile, I guess.
Okay. Sort of relating to that, given the long time frame it took to get the game out, was there any sort of postmortem done on why did it take so long and what could have been done, perhaps using Agile to figure out how to speed that up?
Well, I mean, I think the major problem was that we tried to tackle 7 major technologies all at the same time: a new character animation system, a new rendering technology, new displacement technology, there's new physics, zillions of things all at once. So it was very hard to connect the dots in terms of okay, I'm making this rendering feature and I want it to integrate with all the different systems. When those systems didn't exist,
sure.
It ended up delaying development quite a bit. So in fact, we've very strongly gone towards the direction of iterative technology development, where we try to take one new technology, filter through everything, and immediately ship it over Steam, which falls directly in line with our sort of episodic development ideas. And so, we're measuring how successful that's going to be, but it's definitely an experiment we're running in response to the long tech development that we ran into on Half-Life 2.
All right, thank you.
How did you decide between features that were not playable, or the things that you wanted to scrap, and features that you thought, we just need more training in the game?
Oh, and how did we decide when a feature was a failure?
How could you tell that, if we just keep training the player, they'll know how to do this, and then it will be fun, as opposed to that's just taking too much resources?
There were some things, like the original design of the airboat section of the game was more like a Tony Hawk. You learn these tricks in the airboat, and then you execute the tricks under pressure, like while you're being shot at by the Metro cops. And we deemed that a failure, and not a failure that required more training, more on sort of fundamental principles that it was no fun to fail at a trick and then be shot at by a bunch of guys with machine guns. And we didn't really see a way of solving that trivially. If you fail at your trick, then you're kind of dead in the water for a while. It takes some time to turn around and escape. And that was something we felt was fundamentally not fun, rather than something that just needed to be taught to the player. I suppose if you see an avenue for training a player, if you think this will be fun if they just know how to do it, it's sort of the difference between do they know what they need to do and it's just not fun when they do it, or do they not know what they need to do? And is there some training that we could apply to that problem?
Yeah, I think in general, if we could identify a simple training thing to do, we would typically do it, right? We're playtesting every week, right? So if we could implement something in a week and we're all right, let's just see if that works, we would tend to do it. And once we got to the point where it was actually this element isn't fun, and we've spent some iteration on trying to make it fun, that was much more typically where we would cut stuff.
If you're basing all your design decisions on play testing, how do you source candidates for stuff that's going to show up at the end of the game, where people have been playing the game for 6 hours and they're experts?
Yeah, so the way we solved that problem, or attempted to solve that problem anyways, it's a hard one because we developed some of the end of our game at the very beginning, actually, was, first of all, to make a really prototypey, throwaway training level, which is just like text on the screen, like, hit the E key to pick this thing up, and hit the E key and then you can throw it, and basically trying to train every single mechanic that was in the level, first of all. And then another thing that we often did, like we were training, we did the Citadel at the very end. And so at the time that we did the Citadel, there were a couple other levels that were actually finished that had some combat. So what we did is we would run them through a training level, we would put them in the combat, just, an existing level that happened somewhere earlier in the game, just to get them like their heads wrapped around the game. And then after that, we would bring them in finally to actually play testing the levels. Again, it's not going to, they're not going to have caught all of the training necessarily and all the skill necessarily that they might have had playing the entire game, but I think it got us close enough to where we needed to be.
It's probably worth noting too that we did have some play testers that played the game from beginning to end. They just came back over and over again, which was really great because we would see that progression as they picked up the skills over time.
And that's something you tracked?
Beg your pardon?
That's something you tracked?
Yeah, we would track the sort of the outcomes of each play test.
And who had done them and bring those people back?
Yeah.
We typically did that during alpha.
Right. We knew if a player was playing the game through contiguously or if they were just coming in and playing random parts.
Great. Thanks.
Yeah. Sure.
Bringing that number of people outside of the development team in early before the game's actually been announced, did you have any ways of avoiding, like disclosure of things you didn't want besides just the traditional NDA?
We had some issues with that. But I guess we kind of felt that, first of all, we had everyone sign NDAs, of course, but of course they can post stuff. But I mean, in the end, I kind of think that, the real problem is getting people to care about your game in the first place, and if you've done that, then you've succeeded. And if people, are posting stuff, that means, it seems like they're really excited about it and you've kind of succeeded on that axis. Occasionally what we would do, I remember one instance at when we were first testing the super gravity gun, there was one of the play testers started posting to one of the public forums, and we had contact information for I guess all the play testers that come through. Yeah. And so Eric Johnson shot him a little email and say, hey, would you mind not posting anything more about it, because obviously we don't want everything revealed. And they were fine. I mean, these guys, the people who are coming in, they're your customers and therefore your fans usually. I mean, you're finding them in places like Electronics Boutique, and so usually they're not interested in screwing you, honestly.
All right, thanks.
What role did the story play in the whole playtesting process? Was it kind of nailed down in the beginning, or did it ever change your design ideas, or was the story kind of secondhand in the whole process?
So there was sort of a broad story arc that we wanted to tell. And it laid out there were these key story moments that we knew we wanted to hit, like the teleporter accident in Kleiner's lab, the dramatic sections in Black Mesa East with Eli. And then those were kind of keyframes, and then the areas in between were left deliberately vague until the gameplay was more sort of solid there. And then we went in and sort of inserted story points that reinforced the global story arc in a way that dovetailed, with the gameplay that was there. And the story had to be supple as well to accommodate gameplay discoveries. Like originally, Black Mesa East was after Ravenholm, and when we realized how cool the gravity gun would be in Ravenholm for killing zombies with saw blades and stuff, we actually moved that to before Ravenholm, which was a pretty major story change, but it made the game better, so the story had to just kind of, change to accommodate it.
Thanks.
Sure.
I have two questions. The first is, you guys mentioned that you used Wiki and you also tried to record trends between playtests. how did you just use your wiki, or did you use any other means for identifying trends and taking data away from playtests?
We on Half-Life 2, we didn't have enough instrumentation built in to really graph trends, if that's what you're talking about.
Right.
Trends were obvious.
We kept trends in our heads mostly.
Yeah, I mean, it was really obvious. Like, you're watching every playtest, and you're, in your team of 5 people, and that team of 5 people is making all the decisions about what to do. So at the end of every playtest, like, we have this discussion, like, okay, what were the things we all noticed? What were the things we're going to do about it? And so your every day is focused on solving these problems. So the trends we just never felt we needed to track them because it was obvious, it was just so ingrained in what we were doing.
We have to.
Looks
like we're getting cut off. Sorry, guys.
Thanks.
All right.
Thank you.